Hey, hello neighbor! When we are doing A-star pathfinding, it's really important for all the tiles to know which are its neighbors. That way we can jump from neighbor to neighbor until we reach the target destination. So that's what we're gonna do today. We're gonna find all the neighbors for all the grid shapes. And then we're gonna create a button in the user interface to be able to test all that. So let's get to it! Okay, so in Unreal, the first thing we're gonna do is create the action. That way we're gonna be able to add a button in the user interface and be able to test it as soon as possible. So I went in my core player actions and I created a new folder which I named Pathfinding. And since I'm lazy to create the action, I'm gonna go in my grid folder, select my select tile action and copy it into the Pathfinding folder. Then I rename the action action_showTileNeighbors and then we can open it. And then in the execute action function, I'm just gonna delete all that, I think. We're just gonna keep the add state to tile because we're gonna add a state to the tiles, but with the neighbors instead of the selected. But since we don't have the value in the enum quite yet, I'm just gonna go add it. So entry, go in my grid utilities and open the eTileState enum. And here I added a fourth state for the isNeighbor. Then we can just save this enum and close it. Now back in the execute action function, we're just gonna connect everything so we have a little bit of feedback. So first we have to change the state for the isNeighbor state instead of the selected. Then we can remove the selected tile right here because we're gonna use the index pass as input and we can connect it to the beginning of the function like so. And the last thing we have to set is the color that will be applied to the tile when we are setting the isNeighbor state. And this color is applied in the grid mesh inst. So we're gonna go there. I'm gonna go back in entry, go in my grid utilities and open BP grid mesh inst. And on the left we have the get color from its state, which brings us right here where we are setting the colors. And here I change the color for the isNeighbor for a shade of pink and I can go in my make array, add the new state to it, so isNeighbor at the end as the third index. We can now compile, save this blueprint and close it. Here we go, now the loop is almost done, we just have to add the button to the user interface, so I'm gonna go back in entry and create my button in the debug menu, action, and here I'm actually going to duplicate one button that already exists. I'm going to duplicate button action underscore increase decrease tile height. I renamed it button_action_show_tile_neighbors and we can open the widget. And here in the designer, the first thing I changed is the name of my button on the left, so it's button action show tile neighbors, and I also renamed the text written on my button, so it's written show tile neighbors. For the left click action, I selected the show tile neighbors, and for the right click action, I've set it to none because we're not gonna use it. And then that's it, we can go back in the graph. And here we're gonna need pretty much all that later, but for now we're not gonna use it, so I'm just gonna disconnect the sequence like so. And that's it for now, so I'm just gonna compile and save it and go add it into my debug menu. So go back in entry, go in the debug menu tabs and open the tab Pathfinding. And here we can go in the user created widget, grab our button and drop it into the vertical box. We can also add 2 of padding just to make sure that it is the same as the other one. And we're finally ready to test all that, so I'm just gonna go compile and save this tab, go in the level and press play. Now if I go in my tab Pathfinding, I can select my new action, show tile neighbors on the left. And now if we start drawing on the grid, we can see that the code doesn't really do what we want it to do. It doesn't show us the neighbors, but only selects the tiles that we are overlaying. But since the color is pink, it means that the state it is using to draw the color is the isNeighbor state that we just created, which also means that the code is executed properly. The whole loop is executed and functional, and we just have to focus on the code right now. So that's what we're gonna do. We can just stop and go do that. So for the logic of the action, it is related to the pathfinding, and since I think we're gonna have a ton of code related to the pathfinding, I think it will be a good idea to create a new blueprint instead of directly doing it inside the grid. So I'm gonna go in my core grid folder right here, right beside the grid, and create a new blueprint. So blueprint class and select actor. I named it BP_grid pathfinding and we can open it. And here the first step we have to do is to create a reference to the grid. That way, a little bit like the grid visual, the grid pathfinding is going to know which grid it's going to use to generate the pathfinding. So we're gonna start by adding a new variable for the grid. I named the variable grid and it is of type BPGrid. And now we're gonna go add the pathfinding as a child of our grid. So we can go back in entry and open the BP grid. And here I added a new child actor component, which I named child actor_grid pathfinding, and I also set the child actor class to be BP grid pathfinding that we just created. And now we just have to go link the grid pathfinding to this grid, and we're gonna do that inside the construction script. And we're gonna do it like that. So the same thing we did for the grid visual, we are getting the component, which is the child actor component grid pathfinding that we have right here. We are getting the child actor that is inside it and then cast it to the blueprint class of the child actor, which is BP grid pathfinding in that case. Then we are setting it into a variable so we can use it later. So I have my BP grid pathfinding variable right here that is named grid pathfinding. And then we simply set the grid variable inside the pathfinding. And we're doing that by using self. That way, this pathfinding right here is going to use this grid, like this blueprint right here, as a reference. And that's it for the grid. We're not gonna do anything else inside it for today, so we can just compile, save it, and close it. Okay, now back in the BP grid pathfinding, now that the grid variable is set properly, we can now create the function to get all the tile neighbors. I named the function GetValidTileNeighbors because it's going to also check if the neighbor is valid at the same time as returning it, and we are passing it an index, which is an int point, and it is returning an int point array, which is the neighbors. Then the first step is to check the grid shape, because the return is going to be different depending if we have an hexagon, square, or triangle grid. Because, for example, the square only has 4 neighbors, the hexagon has 6 neighbors, and the triangle has 3 neighbors. So the returns, the neighbors that we're gonna return in this function, are gonna vary depending on the grid shape. And we're gonna start by the square because it's the simplest one, and we are actually going to create a new function to get the indexes for the square. I named the function GetNeighborIndexesForSquare. I'm passing it an index, which is an endpoint, and returning it a list of neighbors, which is a list of endpoints. And for the logic of the function, even though it's pretty simple for a square grid, I still taken a screenshot of the grid that we have right now with the tile indexes written on them. And I also highlighted a few tiles to use them as example. And for this example, the index that we are interested in is the index 00, which is the index that we will receive as input right here. And we want to return the pink tiles, so 1, 0, 0, 1, -1, 0, and 0, -1. And actually, this screenshot tells us exactly what we need to do to access those indexes. For the tile that is above the current index, we have to do +1 on the x, and for the one below it, we have to do -1 on the x. And same thing for the left and right, so we have to do -1 on the y, and then +1 on the y to access those neighbors. And that's how it will look in the code, so we are taking the index and adding an offset to it, and for the offset we are doing the same offset that we had in the screenshot. So for the tile above we are doing +1 in the x, on the right +1 in the y, for the down tile we are doing -1 in the x, and for the left tile we are doing -1 in the y, and then we are making all that into an array and returning it at the end of the function. Function that I will actually make pure here in the top right corner so it's easier to use later on. And now we can go back in our previous function, and here at the end of the function for the square pin we can return the return of the GetNeighborIndexesForSquare, passing it to the index so it knows which index we are talking about. I know that we're not doing any tests right now to make sure that those neighbors are valid before returning them, but actually I just want to be able to see something on the screen and then we can come back and focus on the test later on. And now to display those tiles on the screen, we can just go back in the action showTileNeighbor function and call this new function that we just created in the pathfinding. Which I'm doing just like that. So inside the grid I'm accessing the grid pathfinding, which then I'm using to call the GetValidTileNeighbors for that specific index, and then I'm passing it into a for each loop to add all the states is neighbor state on all of them one by one. And we can now go back in the level and press play just to see the result. I'm gonna go in pathfinding, select my action and click on the grid. And we can see that it displays all the tiles that are neighbors to the highlighted tile. But right now it doesn't clear the grid before showing the new tile neighbors, so we're just gonna stop and go do that. And we're gonna go do that in the BP grid. I know I said that we were done with it for today, but I guess that was a lie. And we're gonna create a new function. And we're gonna use this function to access all the tiles that have this state on them. That way, later on, if we wanna access them for some reason, or in this case, to clear them, we can simply call this function and we're gonna return all the indexes. So I named the function getAllTilesWithState, and I'm passing it a state, which is an enum tile state that we created before, and then I'm returning a list of endpoint, which are the indexes of the tiles that have that state. And for the logic of the function, it's pretty straightforward, so here it is. I'm first starting by getting all the values of my grid tile map, that way I have access to all the structures of all my tiles, and then I'm doing a for each loop on all of them to compare them all one by one. And here we are checking if the states on the tile contains the state that we received as input. And then if it's true, it means that we want to return the index of the tile as output of the function. So I created myself a new local variable which I named array for return, and I'm adding the index to it. And then at the end of my loop, I'm just returning all of them. It's not really the most performant way to do that, but for now it's going to be good enough because we're not going to call this function that often. Okay, now let's go create the function to clear all the states. So new function. I named it ClearStateFromTiles, and I'm passing it a state as input, and I named it the state. And here it's simple, we just have to get all the tiles with the state that we receive as input, and then we can just for each loop through all of them to call the function removeStateFromTile, passing it the index and the state that we received as input, which gives us our ClearStateFromTile function that loops through all the tiles and remove all the states. Okay, perfect. Now we can go use this function into the action showTileNeighbors right here. And I'm calling this new function at the beginning of the execute action. So I'm clearing all the state from tile using the isNeighborTile. Then we can loop through all our neighbors and add the states again. And that's it. We can now go back in the level and play to see how it looks. I'm gonna go in my Pathfinding, show the tile neighbors, and now if I drag around and move and select another tile, it should remove the previously selected tiles. Perfect. We can stop again. So now it works. We now have a function that gives us all the 4 neighbors, adjacent neighbors of the selected tiles. But before going to the next shape, I think it will be interesting to also add the diagonal. So let's say the tile right here, the tile +1 +1, or maybe that one here, -1 +1, -1 -1, and +1 -1. So then later on, we'll be able to decide if we want to move using only the adjacent neighbors, the 4 adjacent neighbors, or if we also want to include the diagonals, so all the 4 corners also. So that's what we're going to do before going to the next shape. And we're going to do that inside the Pathfinding and inside the GetNeighborIndexesForSquare. Here I added a new input, which is a boolean this time, and I named it IncludeDiagonals. So it's going to tell us if we want to include the diagonals inside our array or not. Then I added a branch right here to decide if we want to include the diagonal or not, and if we don't, well, we want to just return the code that we already have because it doesn't include the diagonals like so. But in the case that we want to include the diagonals, instead of returning all these directly, we're just going to set them into a local variable for now, and then we're going to append the diagonals to them. Which we are doing just like that. So we are taking our array that we just created right here, we are appending another array that we are making, and we are passing it all the diagonals, in which we have +1 +1 for the top right corner, -1 +1 for the bottom right corner, -1 -1 for the bottom left, and +1 -1 for the top left. So now our array contains both the adjacent tiles and the diagonals. And finally, we just have to return it at the end of the function. And that's it, we're not with this function, we just have to go and tell it if we want to include the diagonals or not. So I'm just gonna go back in GetValidTileNeighbors right here. And here what I did is just I created a new variable, a boolean, which I named IncludeDiagonals, and I'm passing it into the other function right here. And now we have to go up one more time to pass the parameter to this function, and it is inside the action showTileNeighbors right here. And what I'm going to do is create a new variable for it that we can then change in the user interface. So right click on it and promote it to variable, which I also named IncludeDiagonals. Now we're going to go set it inside the user interface, which is inside the button actions showTileNeighbors. And I'm going to go in the designer first. And here what I did is adding a vertical box around my button. That way I'm able to then add a checkbox inside it. For the checkbox I renamed it so it's checkbox_IncludeDiagonals, and I added it a little bit of padding, 2 of padding to be exact. And finally, inside the checkbox, I added a little bit of text, which is written IncludeDiagonals, the typeface is regular, and the size is 10. Okay, now we can select the checkbox, go all the way at the bottom on the right, and implement the event. And here I just brought the events closer to the other ones, and then I can connect it to the flow like so. And here we're not gonna need the sequence, actually we're not gonna need everything that's in there, and we're also not gonna need that cast right here. We're just gonna keep the selected action left click like so, which we then cast to the new action we just created, so action showTileNeighbors, to make sure that this action is currently selected. And if it is the case, well, we want to set the value of IncludeDiagonals based on the checkbox. So we are getting the checkbox and we're checking if it's checked, and we are passing this into the IncludeDiagonals variable. And the last thing we have to do before we're done with this button is to either hide the checkbox, unshow the checkbox based on if the selected action is the showTileNeighbors or not. So that way we are not showing the checkbox, it is collapsed if it's not the right selected action, but it is visible if the selected action is really show tile neighbors right here. And that's it, we're now good to go. So I'm gonna go back in the level and press play. And now in my pathfinding, if I select my action, I have the new checkbox that pops in. If I deselect it, the checkbox disappear, perfect. And if I check my checkbox, now I have my diagonals around my tile. If I uncheck this checkbox, we just have the adjacent tiles, perfect. So either adjacent or diagonals. Perfect, we can now go do the other tile shapes. Let's go back in the BP pathfinding. This time we're gonna do the hexagon, so we're gonna need a new function the same way we did for the square, so new function. The name is GetNeighborIndexesForHexagon. I'm passing it the index as input and I'm returning a list of neighbor indexes. For the hexagon, we don't really need a diagonal variable because there's not really diagonals for the hexagon tiles. And it's now time for the second screenshot. Here in the middle we have the selected tile and we want to return all the neighbors, which are these tiles. So we have 1, 1, 0, 2, -1, 1, -1, -1, 0, -2, and 1, -1, which are the values that we're gonna add on top of our index that we receive as input to figure out which are the neighbors, and then we can return them at the end of the function. Which gives us something like this. So we have all the 6 tiles surrounding the selected tiles, and the values are pretty similar to the square plus the diagonals, except for the right and the left, because those ones are +2 and -2 instead of +1 and -1. And we can now go back in the main function and connect this new function, but before doing that I just realized that I forgot to make this function pure, so I'm just gonna select it and make it pure, and then we can go back in the GetValidTileNeighbors. And here it's the same thing as for the square, we can just call the new function, give it the new index, and then return the neighbors at the end. Okay, we can now go test it. I'm gonna compile, go play. I'm gonna hide the environment and show an hexagon grid. And now if I go in my pathfinding tab, select my action and click on the grid, yes, it works. I have the right neighbors for the selected tiles. Perfect. Okay, it's now time to do the last grid shape. I'm gonna go in my pathfinding and create a new function for it. The function name is GetNeighborIndexesForTriangle. I'm passing it an index and also a boolean to include the diagonals or not, because I guess for a triangle grid we have diagonals. I'm not really sure about that because it's a weird grid, but I mean, it kinda makes sense. And then at the end of the function I'm returning a list of neighbors like the other ones. And I also made sure to check the pure checkbox this time, I didn't forget it. And it's now time for the third screenshot, but this time we have a little bit of a problem. If you check on the screenshot, you can see that these tiles right here on the left and the right side of the triangles are the same, even if the triangle is upside down or not. But the third tile, the tile that is under the triangle, in this case on the left and above the triangle on the right here, it has different indexes depending if the middle tiles, the selected tile, is upside down or not. So we're gonna have to treat it differently if the triangle is upside down or not. But before adding conditions in the code, we're just gonna start by the ones that are the same in both cases, so the tile that is on the left and the tile that is on the right, because both of them are the same even if the triangle is upside down or not. And it's now time to add the check to check if the triangle is facing up or down. And we're doing that by checking the even or odd status of both indexes, so the x and the y of our endpoint. We are checking if they are even, and if both of them are equal to each other, it means that the triangle is facing up. So if both of them are even, it means that the triangle is facing up, and same thing, if both of them are odd, it means that the triangle is facing up. Otherwise, if they are not equal with each other, it means that the triangle is facing down. And then if the triangle is facing up, we want to add the neighbor that is under it, so we're gonna add the down tile, like so. And then if the triangle is facing down, we are doing the opposite, so we are going to add the tile that is above it. And that's it for the tiles that are adjacent to the selected tiles. But if we want to include the diagonals, this is going to be different. But for now, if we don't want to include the diagonals, we can simply return it because this is the end of the function. And it's now time to do the diagonals. It looks a little bit like this. Right here on the left and on the right, you can see in the green I highlighted the diagonal tiles. And same thing as for the adjacent tiles, the indexes are different depending if the triangle is looking up or looking down, so we're gonna have to do the same kind of comparison and return different indexes in both cases. So here I'm doing the same thing, I'm checking if my triangle is facing up or down. And then if it's facing up, I'm doing an append on my list using these indexes. So I have the tile above it, the tile down right, and the tile down left. And these are the indexes we are using if the triangle is facing down. So we have the tile under it, the tile above in the right corner, and above in the left corner. And that's it. We can finally return the list at the end of the function. Now I'm going back in my main function to call this new function, and we can connect it like so. So we are passing it the index and the diagonals and return the result. Okay, let's go test. I'm gonna go in my level, press play. I'm gonna hide the environment and show the triangle grid this time. And now if we go in the Pathfinding tab and select our action, we can see that the indexes seem to work for the neighbors. So that's good. It doesn't look too bad. Okay, great. And now if we include the diagonals, well, it looks weird, but I mean, that's what we want. That's just weird, I guess, but whatever, that's good enough for now, I guess. Okay, good. So we now have our tiles and all the neighbors for all the grid shape. Perfect. Bon, there's one last thing I want to do before ending this video, and it is to add some checks inside the function so we don't always return everything, like every neighbors that are around the tile that is selected. The first check I want to add is the check for the tile type, because right here you don't really see it because we don't spawn a tile, but the function actually returns the tile that is right here in the empty space, and same thing for the obstacle. Right now the function returns the tiles that are under the obstacles, and we don't want that. We only want the tiles that are walkable, so the tile that a unit can walk on it, not all the other tiles. And the second check that I want to add is a height check, because I don't want my unit to be able to jump from all the way to the bottom here to all the way to the top right there, or vice versa. I don't want them to be able to jump from the top to the bottom, so I'm just gonna compare the height of my tiles to make sure that they are not too high or too low. So back in the function that gets the valid tile neighbors, I'm actually just going to start by duplicating it. I'm gonna duplicate this function because I think it's going to make it a little bit more clean, and I'm going to change its name for GetNeighborIndexes instead. And I'm actually not going to change anything inside this function. I'm just going to go back inside the GetValidTileNeighbors function. And here I'm going to replace everything by the new function we just created. So we can just delete all that, call the new function instead, and connect it. There we go. We now have our neighbor indexes, and we can loop through them to validate them. Then since we're gonna need the data of the tile to access its height or its tile type, I'm just going to get it from the grid tiles and save it into a variable. For the first check, it is pretty simple. We just have to check if the tile type is walkable, and to do that we just get our variable, we split it, we access the tile type, and we check if it is walkable using a branch. For the second check, it's a little bit more complex because we have to compare the transform of this tile with the transform of the tile that we received as input, so we also need to have access to the data of this tile right here. So first, to keep it a little bit more clean, I just disconnected the pin that were connected directly to the GetNeighborIndexes, and I replaced them by the variable instead. And then in between, we are getting inside the grid tiles again, but this time we are using the index that we receive as input, and I'm setting it inside a variable that I named input data. And now that we have the data and the input data, we can just split them until we access the height of the tile, so the location Z right here for both of them. And then we get the height difference between the two tiles by doing that, like so. And then we can finally compare the height difference between those two tiles with the grid tile size Z. That way we're gonna check if the difference between those two tiles is smaller or equal than the height of one tile. And then we can plug that inside a branch. And if the branch is true right here, it means that we want to return the tile at the end of the function because the tile is valid and it is a valid neighbor, so we want to return it. But for now, we don't have a variable to contain all of our tile indexes that we want to return at the end of the function, so we're gonna create a new local variable. I named it RET for return, and it is a list of endpoint. And we can now do an add on the new list with the data index, so we can return it at the end of the function. End of the function that is right here at the end of the for each loop when it's completed, so we're just connected the completed to the return node and connect the variable to the return node also, like so. And I think that's it. We can now go back in the level and test all that. Here I'm going to increase the size of my grid so it includes all the steps right there and generated based on the environment, and then I'm just gonna focus on the step right here. And then if I go in my action and select a tile, I can see that it seems to work. It only includes the tiles that are one tile above the selected tile or one tile under it, but it doesn't include the tiles that are too high or too low, like so. Perfect, it seems to work in both directions and for all my steps. Good. So yeah, I guess that's gonna be it for today. That was a big chunk of work that we did today, so that's good. But for now, we need a break, so I'm gonna see you in the next one. Bye bye!